Hi everyone, my name is Al-Obaidi, and for this project I want to do data analysis with pandas and the Raspberry Pi. I've always been interested in robotics and want to eventually get into artificial intelligence, so I wanted to take this opportunity in combining both worlds. I wanted to take a piece of hardware, which in this case the Raspberry Pi, and collect data constantly, and then in return take this data and analyze it and plot it, and that's done with the help of pandas and Python. So really quick, as pictured in the top left, the Raspberry Pi is a pocket-sized computer, and these 40 pins are known as general purpose input and output pins. And that's kind of like where the magic happens and where we're able to attach different sensor to these pins and begin the data collection. Now down below in the bottom left, when I first got the Raspberry Pi, the first step to take was to install the Raspbian OS on it, which is known as the noobs. And with the help of a USB mouse, a USB keyboard, and through HDMI cable I attached it to a computer screen, and also with an SD card I was able to take that first step, get the Raspberry Pi running, and install the OS on it. And afterwards then comes the ability to really connect these sensors. So I purchased some breadboard and some transistors and jumper wires and a couple of sensors to connect to the Pi. Originally I was going to use the distance sensor, but then I decided to go with this, which is the DHT22 temperature and humidity sensor. It's manufactured by a company known as Adafruit, and it can read between minus 50 degrees Celsius up to 80 degrees Celsius. So it's a pretty accurate sensor, and that's kind of what this project revolves around when it comes to the data collection. So let me show you guys what the Pi looks like really quick. So really quick, this is the Pi, and this is the B plus Raspberry Pi 3 B plus model, and this is the DH22 sensor. And with the help of three male-to-male jumper wires, I was able to attach the sensor to 3 pins on the Pi. Now, on the left-hand side of the screen, you guys will see the diagram. This diagram shows kind of like what these pins are, what they stand for. So in the case of the sensor, I was able to attach pin number 1, which is this black wire. Pin number 1, as you can see on the left-hand side of the screen, this is the one that powers the sensor, which shoots a 3.3 volt power. Pin number 9 is the ground, which is this. Get closer. It's the gray cable. This one right here, and then the white one is the main one, pin number 7. So this white one is the one that is going to collect the data for us, and we will use that in our code. And once again, if you look at the left-hand screen, this is the pin right here, which is the GPIO4, and that's the one that is actually collecting the data. So as you can see, I don't have any USB mouse or keyboard connected to this because I was able to configure remote desktop through which I can connect to the Pi from my own laptop. So without further ado, we will log into the Pi remotely, and I will show you the code that's currently running on the Pi. So before I log into the Raspberry Pi, I'll show you guys a diagram which shows the flow of my project. As mentioned earlier, I have the DH22 sensor connected to the Raspberry Pi. And on the Pi, I have a Jupyter notebook running, and this is where the code, Python code, is written and executed. And I have the Adafruit module running on the notebook, which helps me collect information from the sensor. And most importantly, I also have the Pandas module, which will help me create a data frame of that data. And then I can begin analyzing this data and plotting this data, as we will see shortly. And I can also take this data and send it over to matplotlib, from which I can create some charts and also analyze data. So I'll go ahead and log in to the Pi. So I'm using Microsoft Remote Desktop to connect to the Pi. entering the username and the password. And this is the Raspberry Pi console. So as you can see, this is Jupyter Notebook currently running on the Pi. So I'll go over the code really quickly and then we'll execute it. So I try to divide up the cells so they will be coherent for the user. In this first cell, as we can see, this is where all the libraries are imported. We have the Pandas, the Matplotlib, and also, as I mentioned, the Adafruit DHT module, which we will see shortly, the methods that we're calling upon to help enable the sensor. And we're also using time, date time, and PYTZ. Now in the second cell, we do kind of quick initialization of some parameters. As I mentioned, I've imported PYTZ, so we declare the time zone to be the US Pacific since I'm currently in California. And then I set the sensor to 22. So 22 is short for the model of the sensor. So in this case, DH22 and is what being used in the project. Thus, I'm setting this to 22. And as you guys remember, as when I showed you earlier, the white cable that was connected from the sensor to the Raspberry Pi, it is connected at GPIO pin number 4. And that is why it's important to keep track of what pin you have connected the sensor to on the Pi. So these two variables will be passed down to a method that I will show you guys shortly. And I'm also initializing some list. The humidity list holds the humidity data from the sensor. The C list holds the Celsius temperature data from the sensor. The F list is the Fahrenheit temperature data from the sensor. And then the dates will hold the date and time the data was captured. So if we move on to the next cell, I will initialize these cells, run, and then now we go into the data collection. And this is really the main cell. So I have the code is going into a while true loop, and the only way it will be stopped unless the sensor can't read any data and there's an error, or there's a keyboard interrupt from the user. So in this loop, the humidity and the Celsius temperature is being recorded by the Adafruit DHT.read-retry method. And this method, which is part of the Adafruit module, it takes the sensor info and the pin info, which we declared in the above cell right here. It takes that and feeds it into the read-retry method. And this method will try 15 times to get a sensor reading. And once it gets a sensor reading, it returns to us the humidity and the Celsius temperature. And since I have the Celsius temperature, once I have that, I can then convert that into Fahrenheit temperature with the below formula. So then, for every reading, we will have a humidity reading, Celsius temperature reading, and a Fahrenheit temperature reading. And once we have that, we can then append the appropriate list with the information. So in this case, it's a humidity list, the Celsius list, and the Fahrenheit list. We will feed that data into those lists as a collection or as the data is being accumulated. And also, most importantly, I'd like to record the time of data collection, and I will do that using the datetime.now module, and I will also use a time zone specified earlier, which is the US Pacific time zone. So this will enable me, when creating the data frame, to really use a date-time index, which I will show in the future. And the date time that's being collected will also be added to the appropriate list. So as this is all running, I'd like the user with this code, with this piece of code, to see the data currently being collected. And I will show you what it looks like once I run it. So this will be run, this will continue to run unless the sensor cannot get a reading, because it will try 15 times to get one reading, and at which case it will stop, or I will do a keyboard interrupt, but since we're running this on Jupyter Notebook, I will have to go to kernel and interrupt it. So if I run this, now one thing to take note is that every time a sensor gets information, I will have the code go to sleep. In this case, I want to go to sleep for 60 seconds because I want to collect temperature and humidity information every minute as a program is running. Now later on, for the sake of this project, I want it to run for like a few hours. But later on, if I'm having it run for a few days, I will probably do this every 15 minutes and not as often as 60 seconds. So as you can see, I just executed the program and the code, and this is the first reading that it's returning, and it's showing us the temperature is 23 Celsius, 73.4 Fahrenheit, and humidity is 53.8, and it will wait 60 seconds, and it will continue to do so. And right now it is 2:43 p.m. On Wednesday, December 5th. So I'll let it run for a few hours, and then we'll go ahead and analyze the code afterwards. Okay, so the script has been running for some time now. I believe it's been running for about 7 hours. As we can see, data has been accumulated in the past 7 hours. So I'm going to stop the script running by going to the kernel and then clicking on interrupts. So if I scroll down to the bottom, we will see the message that the measurement was stopped by the user. So now that we have the data all compiled into the different lists that were created earlier, I'm going to use those lists and then convert them into a Panda data frame. So first I create the variable data, which is a dictionary that is composed of 3 key to value pairs. And as you can see, we have Celsius, which is composed of the Celsius temperature list, and Fahrenheit with the F list, and the humidity with the humidity list. And when I create the Pandas data frame, I'm going to use the data to input into the data frame, and I'm going to use the list dates as the index of the data frame. So in this case, it's going to be a date time index. And just to kind of, as a reminder, these are the lists that were used earlier prior to the data collection. So if I run this cell, so now we have a data frame created in memory. So the next step that I want to do is to take this data frame and to output it into a CSV file with the help of the with the help of the toCSV command that comes built in with Pandas. So I'm going to run this cell, and in return, I get a message that says temperature and humidity data has been recorded and saved as sensor data.csv in the following directory. And if I look into this directory, we can see that in fact we have this spreadsheet or CSV file, and it has the following index as a column, a daytime index, and we have Celsius, Fahrenheit, and humidity as the data being collected. Okay, so if we go back to the script, we then now move on to the data visualization part. So in visualizing the data, I want to take advantage of 2 things. I wanted to use the Pandas built-in data visualization capability, or built-in plots, and I also wanted to use matplotlib. So in the Pandas built-in plot, I basically wanted to plot it with a line plot and an area plot. So if I run the cell and we give it a couple of minutes in creating the plots, we can see now we have 2 plots. The first one is the default line plot. At the bottom is basically the index of the time, and on the left hand side are the numbers which correspond to the Celsius, Fahrenheit, and humidity, and that's the legend right here that shows that. And I do believe that when it comes down to the index, right now it shows the day that the data has been accumulated. So it shows that this is December 12th, 5th, and it started at 15th hour, and this is all the way to December 5th to the 22nd hour. And the same thing below, this is the plot, this is the area plot that was created for the data. And now let's scroll to this cell and to plot the data using matplotlib. So I want to take advantage of the subplot, and specifically I wanted to plot a 1:3 subplot. And the plots will take the data from the data frame, specifically the Fahrenheit, Celsius, and humidity data, and it will plot them as a histogram. So if I run this cell, give it a couple of seconds, we see that I have a subplot, a 1:3 subplot of histograms. This is a Fahrenheit histogram, a Celsius histogram, and a humidity histogram, and it's spaced out and labeled the same way that I described it in the above cell. And to really to look at them, for example, briefly, we can see that in the humidity, most of the data that was collected for most of the minutes, it fell in around the 53 percentile. And the same thing could be applied for the Fahrenheit and the Celsius. We can basically create more plots with Pandas and Matplotlib and really dig deeper into analyzing the data and get a better visual. So now that we kind of have some plots and graphs, we can move on to the data analysis using certain commands. So I'm going to run this cell. So this command, for example, the df.columns, I want to double check to see the columns that are listed in the data frame. And as I can see, it is in fact Celsius, Fahrenheit, and humidity. And for the index, if I run that, the df.index, it does return a date time index, just as I planned for. Now to see the number of items, or so to speak, the number of minutes that were recorded, the sensor has recorded, I will use the df.count. And it appears that 437 minutes have been recorded, so to speak, or 437 times the sensor ran and recorded the Celsius, Fahrenheit, and humidity data. Now the df.max will return the maximum temperature and humidity that was recorded. So if I run that one, we see the following values. It seems like that the hottest that it got so far in the past 7 hours is 77 degrees Fahrenheit with a humidity of 56%. And in return, I can also run the minimum temperature and humidity recorded. Excuse me for this typo. And if I run that one, and I see that in the past 7 hours, the lowest temperature was 71 degree Fahrenheit with a humidity of 47%. And it did rain in the past 7 hours on this Wednesday, so that might have had to play with the temperature change. And running the df.mean kind of returns the average temperature in Celsius and Fahrenheit and humidity. And we can see that the average is 74% and 51% humidity, 74 degree Fahrenheit and 23 degree Celsius, and 51% humidity. And we can also run the df.std, which is a standard deviation, and voila, we have that information. And now we can even start playing, since we're using the timestamps and date time, I can set the start date to return to me basically the timestamp at which the data was initially recorded. So this is the timestamp of the first data. So I'm basically going into the index and retrieving the first value of the index. And in this case, it's December 5th, 2018 at 14 hour, which is 2 p.m. 2 p.m. 43 minutes and 26 seconds, and these are the nanoseconds. And as we see here, the -8 stands for the US and Pacific time zone value. So start date is the first time the data was collected, and in return I can check the last timestamp of the index, and in this case the last data that was collected is at same day, and it's at 22 hour 10 minutes and 5 seconds, and this is the nanoseconds. Okay, so now with the fact that I use the timestamp, the Pandas timestamp, I'm now able to really get the difference, a time delta difference. So if I run this, if I take end date and subtract it by the start date, I can now see that this script has been running for 7 hours, 26 minutes, and 39 seconds, and the following nanoseconds. So the beauty about this is I can create my own time delta. In this case, I can take the time delta of 0 days, 1 hour, and 15 minutes, and then I can basically go into the data frame and I can kind of, with the power of indexing, I can retrieve the data from the start date, which in this case is this following timestamp at 14 hours, 43 minutes, and then add to it a time delta of whatever I'd like. So in this case, I want 1 hour and 15 minutes. So if I run this, I get the following list. I can go on and on and on, and I can even shorten that. So it says it's 74 rows and 3 columns. So there are 74 entries according to the time delta that I entered. And I can also run a Boolean with this statement in which I'm asking the data frame to return to me any data at which Fahrenheit is above 75 degrees. So if I hit run, we get the following data back, and this list 177 rows, so it's basically 177 timestamps where Fahrenheit is above 75 degrees, and the accompanying data of humidity and Celsius. And right below we have df.describe, which kind of summarizes some of the commands that I've already ran above. So overall, this kind of demonstrates Pandas' capability in data analysis and visualization. So, I can go on in asking Pandas to give me more information and run more commands, and I can even combine different data sets. If I have another sensor, I can take that data set and combine it with this one if it's the same sensor, and then go ahead and analyze it further. So I definitely learned one of the biggest lessons is Pandas' overall capabilities in not only data handling and analysis, but in data plotting. And I really enjoyed this project in combining hardware and software. And some of the obstacles I ran into, which is expected, is really just configuring the Raspberry and the Python libraries. But overall, it was a great experience for me to gathering this knowledge and using Pandas' power in data handling. And I'm sorry that this presentation went longer than expected, and I hope that you guys enjoyed it. Thank you.